Am I audible? Just someone.
You're audible
Yeah,
enough.
Yes,
cool, cool.
yes, yes.
Yeah, cool, cool, cool. Yeah. Sorry for the inconvenience. Yeah. Now, like last time, in the last class, we did binary search in 1D. So binary search, if you guys know, it's just like, I mean, I will just give you some, one example because people have joined right now, right? Uh, so it's just that in 1D, what we do is that it's a another efficient way to find any kind of element from an array, right? Where we use basically pointers, right? See, like in a traditional search, what we do is that let's say that you need to find n. If you need to find nine element in this array, right? You will go and you will iterate through this whole array, right? And then maybe you will get this array, so which will be a little bit more time consuming thing, right? Because you have to iterate the whole array. Let's say that you need to search the 17 element, right, which is right here at the end. So that means that you need to go till the end of the array, right? So which means that you need to iterate through the whole array. So what we do in binary search is that we make two pointers, right? And this works only when the array is sorted, as in the array is increasing in this order, right? Using these two pointers, we find middle element and then compare the middle element. That if compare this element with the with the element we need to find. Let's say that we need to find 16. So do you think, like, and we see the, okay, mid is here, sorry, low will be here, yeah. So do you, now mid has 9, so do you think 16 will come before 9 when the array is sorted? No, right? Because 9, like before 9 every element will be lesser than 9, which is itself lesser than 16, right? So we will update our low pointer to the next element and then we will search in this. So basically we are halving the arrays, right? You can see we are halving the spaces out. So whenever you find something, whenever, first of all, there's one trick. Whenever you find a question, you just note that the people who are new here, just note that if you see sorted array, apply binary search. Try to apply binary search because most of the questions deal with this only. Again, in an interview, make one more point that whenever you see sorted array, when a interview coding round is happening, you don't directly jump to binary search. First, do the brute force method, as in brute force, as in the normal linear search. Then go to binary search, because in an interview, like interviewer sees your thought process, right? He or she doesn't like. If you directly go jump to binary search, the interviewer will think that you already know this problem and maybe will give you another problem, right? Or maybe he won't be that much impressed, right? So it's always better to start with the brute force method and then go with the binary search. So this is just about the binary search. I will be uploading the video in a short time, so you guys can see. Again, fine. Now coming to binary search in 2D. So this kind of topic is little bit complex for people, but again, I will try to make it as easy as possible. So again, as I told in the interview, what happens that we need to go to brute force method first. So first of all, this is a 2D array. 1D array was just it just had one, it was in one dimension. There we have two dimensions, right? Uh, okay. Meghna, just to like note, can we do something like this that some of, like, any one of you guys have the access to admit the new people who are joining in between classes? Can we do that in Google Meet? I'm not aware of it.
Yeah,
Meghna?
I think if one of us is the host,
Yeah.
then like co-host, then we can do it.
Yeah, can I make you guys who host, like, whoever?
Yeah, make me and Meghna for today.
Yeah, how can I make it? Like, can you wait, Bhuvan, right? I can just make you contributors. Uh, no, I guess you guys are just contributors. I really don't know how to make. Hmm. Hmm. Okay, fine. It's fine. We will figure it out later on.
Yeah, okay. If I find, I'll just
Yeah,
let you
just, yeah, just let me know. Okay, fine.
know. Okay.
From next class we will do that. Fine.
Yeah.
Yeah. So in binary search, it's a 2D array. You guys can see now. If the question comes that if you need to find an number which is like 32, right? What will be your first brute force method? What will be your first brute force method? Also, you guys can see this matrix is 3, 4, 7, 9, and then again 12, 19, 20, 21, then 26, 28, 32, 34, right? So which means that it's going like this, right? But before seeing this pattern, if you guys want to, if the question means ask that find the target. Let's say that a target is 32. You need to find this element. You need to, return if this exists in this matrix or not. Basically, you need to return true or false. So what's your first brute force method? What's the first solution which you guys think? You guys can, anyone can unmute and, answer. It's fine if it's weird. If you guys think that's your solution is weird, it's fine. The first solution is always weird, trust me. This is the best thing to do. Like, the first solution should always be brute force, should always be, if it, even if it's inefficient, it's fine. So you guys can unmute and tell.
We will traverse row by row and check
Row
if
by row.
every element
Hmm.
matches the target
Yeah,
element.
exactly. Yeah, so yeah, we can do that. Like, let's say we have done something like for I is equal to 0, I is less than um, n minus 1. Let me change the font once. Yeah. And where n is equal to 3 and 4, n means the row and m is the column, which is 4. Like, you guys can see 4 columns, right? N minus 1. I plus plus, we can have these, which solution he gave. We can have two, again, we one pointer can, go with, one pointer can go with the row and one pointer can go with the column. So this is the most inefficient way, but yeah, again, it's a solution. So we need to tell that this to the interviewer again, right? So j plus plus, and then, if, again, if matrix. Okay, one more thing you guys should know, I forgot to tell. Like, let's say this is a definition of matrix, right? If we are writing matrix, this is like, if we want to define this matrix, what should be the thing? It should be row x col. Sorry, row and col. Fine. So in this case, we are defining the matrix like this. So in this case, what will be the rows? Number of rows, which is number of rows is 3, right? And the columns are 4. So we will define rows, like the whole matrix, like this, right? Now if we write this thing, what will this signify? Matrix 3, what will this signify?
A row matrix?
Yeah, exactly. And if we write like this, then basically the first thing is signifies row, right? So the second one means column. So basically this signifies the first column. So basically only this part. Got it? This will signify only this part. It's just like naming convention. I mean, the way how we define the matrix. I just wanted to tell you guys. Fine. So, coming back to the solution, like now, if matrix of I and J, again, those pointers were pointing at each elements, right? So, if the matrix I, J matches with the target, then you just return what? True. Else, you return false. Got it? So, so this is the so can someone tell, like, from the previous class, what can be the time complexity of this solution? Time complexity.
Big of n square. There is two for loop
Again, big of n square. When you say big of n square, what is n, meaning of n?
and number of elements in a row.
Yeah, so do we just have number of elements in a row? Don't we have number of columns as well? So what can,
We
like,
have
O of
column also,
n
no?
Will be bigger than m.
and m,
Uh,
exactly, yeah. So we need to, whenever you guys say n, you need to know what exactly n means there, right? You can't say n square, but again, this means n square only, right? N cross m. Just hold on for a second. Yeah. Am I audible? Is this recording me? Yeah. Hello?
Yeah, yeah,
Yeah,
audible.
cool, cool. So where were we? Yeah. So this is O n into m, right? O n x m, which means n means row number of rows and m means number of columns. Fine. Um, Now we can do one thing. Now this is the most inefficient way. We can make it more, better thing. So one crazy thought can come in anyone's mind, like we can apply binary search here since the arrays are sorted, right? So like the 3, 4, 7, 9, 12, 19, this is going like this, right? So which means that every row is kind of sorted, right? So you guys can apply binary search in each row. Can you guys think like that? Like binary search in each row, because the arrays, because the rows are sorted, right? So we can apply binary search in each row, at each row. What we can do here for applying that, this is the second approach. Uh, second, second approach. Just hold on. Yeah, yeah. So second approach will be like applying. So how we will start this, we can do that. First we will iterate through all the rows, right? We like, what I'm doing currently is, now I'm, yeah, I'm making more, if I'm trying to find more efficient ways. So what we can do is we can, like instead of iterating through all the, like instead of using j, iterating through all the columns, we can iterate to all the rows, like this, and when we go to this row, we can see, we can apply binary search. If the element doesn't exist, then go to next row. If element doesn't exist here, then go to next last row. If the element exists, return. Got the approach?
Can we do one more thing? Like, can we just check the first element of each row? And if we see that the first element is lesser than or greater than the target, then we can go through only that row, right? We can do that also.
Yeah, that was coming to, I was coming to that in the next one. We can do that as well. Can you try to find what will be the time complexity of that approach? At like, let's just see this approach, then we will come to that as well. Fine, we can do that as well. Like seeing all the since, because like as the question demanded that this is in this way, we can do that as well. Right, but again, yeah, just try to find the time complexity of that approach. Right, so for like I'm going to each row and then applying the binary search. Right, so I can just say that if matrix of I is a matrix of I 0 is less than target, right? Then, and target is, let's say that it is less than matrix of I, matrix of I m minus 1, because we are like, because uh, this just has this problem that it doesn't have this correct spacing. But you get the point, right? We are basically just seeing if the matrix I is less than target and target is less than this thing. So just return with the binary search function, which takes the matrix of I and the target again. I mean, if you guys have referred to the last class, the binary search function, if the binary search function exists, we can apply this binary search function. Actually looks like this only. I'm just exactly using that thing. Where is it? Arrays, and yeah, so finding one square. Yeah, the recursive ones. This is the binary search example. Maybe you guys can use any one of it. It's just like the number of, I mean, the number of inputs it takes. It depends on that. But yeah, you guys can apply binary search in that row. Again, this is also not the best solution. That's why I'm not focusing much into this. I mean, just to tell the interviewer before coding only, you guys can, tell your approach. Like one girl said that we can compare that function. That's also right. I guess we will proceed with that. But again, yeah, with coming to this function, we can see that like how much, what can be time complexity of this. So again, since we are moving to each row, right? So first the time complexity can be O of n, fine, O of n. But also we are doing the time complexity, we are doing the binary search at each level, as at each row, right? So plus O of log m, which ultimately becomes what? Can someone answer that?
OFN.
Yeah, it actually becomes O of n, but again O of log m, I mean log m. Why? Because we are focusing on the, I mean the column side. So yeah, it becomes O of n, but for interview, just like just tell everything, like how you are thinking, what is your time complexity at this approach, so that the interviewer knows that you know these things, right? So we can make this approach more optimized, right? So has anyone thought of this crazy approach which I was talking, to make this 2D array into a 1D array and then doing the binary search? Can someone, like flatten this 2D array into 1D, which means that if this is the like I can make this as 3 4 5 3 4 7 9 12 and whatever till 34. I can, and then I can apply binary search here as well. Will that be efficient approach? Can so again, like if you need to make now there are two parts in this thing, in this approach. If you need to make this whole matrix as a 2D, okay, okay, before going that, see, so time complexity, for if we do this, time complexity of this approach would be O of log n, right? Of log in n into m, actually nm, because they are n into m elements, number of elements, right? Which means that O of log n, which is better than at least this approach, right? Because we are adding of n here, right? Yeah, but no, this is actually much more worse approach, because to make this whole 2D array into 1D array, we are also doing O of n into m, right? N into m, right? Because we have to go through all the elements and make it again, to 1D array, right? So this approach is also weird, right? But now, like, I mean, this can be, utilized. You guys can see these numbers here. I have written in red, like 0 1 2 3 4 5 6 7 8 9 10. So this is the hint. Like, this is the only approach which we can use to get an efficient approach. But how to eradicate this thing? How can we not like use this? We can just depend on this one. How can we number these elements like 0 1 2 3 4 5 6 7 8 9 10? So that now we have to think this thing, right? How we will see, like how we will be make that relation. Let's see how. So I will take this here. Fine. Yeah. So whenever you need to find, whenever you are making some 2D matrix an efficient way, you need to find relations here. So first, you guys know the indexing of 2D array 0 1 2 3 0 1 2 3. Fine. Uh, Here you need to see 0 1 2 3 4. You need to find relation between each column and row, right? Column and row. Let's say that, I will give you one example. Okay, let's say that we need to find 19. Fine, 19. So what will be the coordinates of 19? Can someone tell? I explained that earlier as well. What will be the coordinate for 19? Like with respect to row and number of row and column indexing, what will be the index of 19?
1 1.
1 comma 1. Exactly. Yeah. So, and okay, yeah. So, but this in 2D, this is the coordinate. But in 1D, what is the index of 19? 5, right? So basically what we are trying to do here is that we are, instead of converting the whole matrix to 1D, can we convert the 2D matrix, the index of 2D matrix, to a index of 1D matrix, and then apply the binary search? Are you getting my point? Like, we are not transforming the whole matrix into 1D. We are just assigning these index, these red points, right? So we need to figure out how to make this 1 comma 1 to 5, right? So this is the main thing. Now you guys can think and see, like, 5, and there's 1 and 1, and also note that n is equal to uh, 3 and m is equal to 4. You guys can you guys should consider the n m values as well. So to convert this coordinate system into this 1D coordinate system, what we can use, what we can do, like 3 we have n m, we have these rows and number of values, right? So what we can do, we have to think that only, right? So again, when doing these types of problems, we need to we need to observe first, right? So let's see that in this 0 1 2 3 4 5 6 7, so this is just a recurring pattern, right? This doesn't makes gives any much of hint that it's just indexing, right? Can we see the column 0 4 8, right? 1 5 9, fine. 2 6 10. So can we say that these are kind of forming a multiple of 4, right? You need to find some pattern, multiple of 4. These things are finding like these are multiple 4s, right? This is not, but again we just saw this is kind of multiple of 4, 0 4 8, right? As we go down, right? So like just seeing these things, uh, you guys can like also see that first element of every row is multiple of 4. You guys can see 0 4 8. That's what the point is, right? Now for for seeing now, we can divide this into two. Like if we want 5 here, if we are given 5 index, what we can do to get 1 comma 1, right? I can say it's like, I mean, these things are like, at first it's very tough to think, but if I tell you this approach right now, you guys can apply this same approach to other 2D patterns and 2D matrices and find the patterns, right? So for row, what I can do is index of end is equal to m, right? So now I can say if this row, like just consider this is row and this is column, fine. Just hold on, you guys will get my point, Abhi. Just hold on. So let's say that this is a row and column, right? Now row is index upon m, where is 4, so 5 by 4, which comes out to be 1. I mean it is 1 point something, but again we take this floor value, right? So 1, again this we found something like 5 by 4 1. So which means that if we are standing right here, right, we are standing right here, we see 5 by 4 will be 1, so which means that it's giving kinda 1, right? 5 by 4 1, cool. 1 now come now again, doing the same thing to row, like here 4 by 6, will is that coming out to be 1? 4 ones are 4, yeah. uh, 4 ones are 4, right? So 1, it is coming, yeah. 7 by 4, is it coming as 1? 4 by 4, is it coming as 1? Yeah, you guys can see, right? If we divide the index by the number of columns, we can get the one coordinate, right? Now we are just finding out the relation, right? So this is the relation which we concluded to be, right? You guys getting my point? Is someone having any problem, kind of problem, you can tell. But this is the pattern which we're trying to find out. I mean at first this looks tough again, but as you do the questions, you will have the habit to find these types of patterns, right? So we found this pattern, like row can be defined as index by m, which is ultimately 1. I mean just the example, right? Now coming to the column, coming to the column uh, coming to the column, should I erase this? I will just copy this again. Fine. Coming to the column one. Yeah. So coming to the column one, we see that we have 1 5 9 1. Okay, 0 4 8. We found some kind of multiple of 4 here, right? 2 6 10. Again, what we can do here is that to find a relation between column and this column and index of a particular thing, what we can do, taking again the example of 5, we can have this this operator with m, right? Which means that which is 5 remainder of, remainder of with the 4, which will gives us as a 1. So this is giving 1, this was giving 1 as well, so it's the same thing, right? Let's try with another, let's try with the another example, like let's say that 10, right? 10, fine. So for row, what we did for row was the 10 by 4, which was coming, which came out to be, which comes out to be 2, right? So this signifies 2. That's right. The row approach is fine. Now using this thing, again these patterns, you guys, it's tough to crack this at first, but again now I'm telling you this approach. Now what you can do is that always when you will see the 2D pattern, you guys can, find relations like this. So again, column, which means index is 10, and the which is 4. So again this comes out to be 2 as well, right? Because so basically we also found, so this is 2. So basically we found the relation for row and column as well, right? So in this way, we actually found some relation between the indexes of 1D and 2D. Got my point? Is anyone having some problem with this thing, like finding the rows and columns and then relating it to this one? If someone finds any problem, just let me know, because this thing is kind of tough to digest right now. But as you do the questions, again, this all depends on how many questions you practice. Fine. So uh, yeah, again, yeah, so we got these two relations, right? I guess now we can perform, instead of transforming this whole 2D matrix to 1D, we can use this indexing formula which we derived, and write a approach, right? So what I can do, I will quickly write it. So while, again, just like how binary search was, again low high. So basically what we are doing here is that instead of plotting the whole 1D array, we are performing binary search, just keeping out this 0, 1, 2, 3, 4 elements, because we found some relation. I will tell you how we will use this formula here only. I will just write the basic formula, right? So middle, how middle is defined: low plus high by 2. Fine, this is the middle. Also now we will define a new row, like the row which we are iterating through. Row will be this, and the column, the formula which we derived was mid uh, m, right? This is the formula which we derived. I'm just writing that. Now if matrix of row column, now we are exactly using the row and column which we defined in the matrix, right? If the this is equals the target, then return true. Fine. Else, if exactly like binary search now, else if matrix is like the matrix, that coordinate system is, let's say, smaller than target, then low will be again exactly like binary search which we discussed in the last class. This will be, the low will be updated, and else the last condition where high will be updated, mid minus 1. Fine. Else if you don't find the uh, element, just return the false one. So this is the basic approach, right? What we did exactly here is that, just to summarize, we saw this matrix. We saw that okay, we can convert it to 1D, but that will be a tiresome, that will be very complex thing. So what we did is that we found some kind of relation between the index of 1D and 2D. So we can transform row and index, right? Like this, we can update row column, and then it's just apply the binary search here only, right? So this is how you need to think. Fine. And the time complexity of this would be, how much would be the time complexity of this approach? Can someone tell now? Am I audible? Hello? Hello?
Mm, I think there is one loop, so
We are applying binary search. Yeah, yeah, right. We are halving the term. So again, it will be log n, right? Log m.
Yeah.
Yeah, so that will be the, I mean, we just, what we did here is that we just, cross this, we are just applying this, right? So this is the most efficient way, right? You guys now can, define, you guys can now realize this is the most efficient way. Another 2D problem which I have right now is, does anyone have any problem with this approach? I mean, I will, you guys can see the recording again and understand, but this is how, like, if the matrix again, this will be only, will only work if the sequencing of matrix is like in this pattern, right? Like this, if it goes from here, 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 because we are making these index SA, right? So again, does anyone have, is anyone having any kind of problem in this approach? No, right? We can move to another one. Fine. Uh,
Yes, sir.
yeah. Just don't call me sir. I'm a final year student. Okay. So yeah. Anyways, now we have this. Can someone see this 2D matrix and tell me, like, just observe and tell me how is this matrix different from the earlier matrix which we saw? Can someone just tell and unmute themselves?
Mm,
Try to think. Take your time.
it is sorted in the row manner.
It is sorted in the row manner. Okay, yeah, that's a good observation. Now, is it sorted in like the earlier way, like this?
No, no, no.
No, right. So you can see another one more thing. You can see that every row is also sorted, right? 3, 6, 9, 16, 20, 10, 13, 12. So yeah, every row is sorted here, right? You guys can see that, right? So now we can't apply that approach which we did in the last one, right? Because the matrix is not sorted in that kind of way, right? It is sorted in each row. I mean, uh, no, I should not write that. Is every row is sorted. Every row is sorted. Fine. So that is thing which you guys can conclude from here, Abhi. Uh, Now again, starting from brute force method, what can be the most brute force method you guys can think right now? Just tell me that.
Mm, traversing every element.
Traversing every element, okay, and little more to that. Yeah, that will be O of n square. That's fine. Okay. Now next, how can you make it more efficient? Next thing, what you can do? Again, the hint is here.
Bi-
Every row is sorted, right? What you can do here?
Binary search for each row.
For each row, exactly. Yeah, correct, correct, correct. Yeah, so we can apply binary search for each row, but again, let's find out if that is the most efficient way, or is there any kind of another way, right? So we can just, I is equal to 0, it goes till n minus 1. Fine, I'm just writing a pseudocode, and where index will be binary search. We will apply, like, first in this loop, we are just applying the loop which goes through every row, and then at every row it will perform in binary search, taking the taking the matrix I, which means the row, and the target, comparing with the target, right? Because in the binary search we are inputting these two matrices, right? And if this comes out, if index is not equal to minus 1, right? I mean, if we found, return this uh, I, and I mean, just return the ij which we found, right? So basically, again, what is this approach? What's the time complexity of this thing now? Can someone tell now? O of 1. First, we are traversing through every, rows. So O of n, right? O of n. But again, inside this only, we are, applying the binary search as well, right? So this will be low of n. This will be the final time complexity of this thing. Does anyone have any problem with this, like understanding time complexity and all? They can unmute themselves and tell. I can't see the hands raised because obviously I'm in the screen, so they can unmute and tell that I didn't understand this. No, right? So I will assume everyone has understood till now. So now again, we can make this more efficient. We can make this more efficient if we, if we try to again think little in a different way, right? So here indexing won't be any kind of useful here, right? So let's say that we are trying to we are finding some target, as in, let's say, what should I take? 14. Okay, because it's here, right? So we will be doing that all to reach till the end, right? Let's say we have 14. Fine. Yeah. So if we start from, let's say that this is, we know the sorted one, right? Let's say that we start from here, like, I'm just like assuming that 1 4 7 5 15. So starting from here, do you think the 40 number will exist in this row in 1 4 7 11 15? I mean, just by seeing 15, do you think this 14 can exist before in this row?
Yeah, it may.
It may, right? So that's fine. We can consider this row. But now see this column. Do you think 14 can exist in this column? Again, you guys need to, like, every row is sorted. Again, you need to observe one more thing, that the column is increasing, right? You guys can see that each column 4 5 6 13 7 8 9 14. You guys can see the column is increasing, right? 1 2 3 10, right? So, like, starting from here, do you think 14 can exist anywhere after, like, in this column below 15?
Never.
No, right? So what, can we discard this column? Like, can we not, just exactly like how binary search works, can we discard this half, like how we used to discard halves in the 1D array when applying with binary search? Can we discard this column completely, right? We can discard
Yeah, yeah,
this. Yeah.
yeah.
So what we can do is that 15 doesn't exist here. We can go to, like, 19. We can go to here. Like, we can update our pointer to here. Now see, do you think 14 exists here? Like, in this I mean, before 12 in this row?
No,
No. So again, I can discard this. Or also, when you are discarding this, this is already, less than 12 itself, right? So we are discarding this whole thing, right? Now we can update our this to here, right? See, you are seeing the pattern right now. Now, do you think 16? Now, do you think 14 exists anywhere in this column?
yeah, it
Sorry, in
can.
this row. Yeah, it can exist. So we will consider this. But do you think it exists here? No.
Never, never.
Yeah. So again, we will update our pointer to 9. Fine. You are seeing the pattern. We are discarding the rows and columns by comparing it to the like the at most end of the matrix, right? Because it's the end. At the end of the matrix, it will be the highest one, right? So we are comparing with that to the target and seeing, discarding the halves. Now coming to 9. Does 14 exist in this row? No, because 9, it is more than 9. Now we are updating to here. Now we see, okay, the matrix I comma j, so is like here only. So we will return the index of uh, j and I. Got this approach? Everyone is clear with this approach?
Uh, Abhinav,
Yeah.
how will with the pointer moving? Are we using two pointer?
No, I mean, kind of, because we are using the row and the column. Whenever we are applying the binary search, basically what we are doing is, in the first thing, what we did, this was the row pointer. I'm just using the row pointer, and this is the column pointer. So whenever we are, like, when you are updating, the column would go here, and the row will be, like, again updated to here only. So when I code this solution, you guys will see we are again using the two pointers. We are not using one pointer, because we are considering a particular space of searching, right? So we have to use two pointers, right? So again, I will just, now use these two pointers. Like, we can define row as uh, We can define row as, let's say, 0, and the column here was the 4, right? Because the it is 0, 1, 2, 3, 4. Actually, it's 5, right? uh, if you do the same operation here, you guys can see that we are at every, like, after every check, we are updating our, like, we are subtracting the column, so we are kind of going 4. We are increasing our row, so we're going to 1. So again, like, if we, when we are, when we jump from 15 to 19, when we jump from 19 to 12, sorry, 15 to 12, my bad, 15 to 12, what we did, column minus minus, kind of, right? 15 to column, we are, like, this is the fifth column, this is the fourth column, so we jumped from this column to this column, so kind of we are doing this, right? And the row was just going here and here, so row was getting plus plus and column was getting minus minus. So we kind of, increasing and decreasing in this fashion, right? And like this only we will get our the required row column numbers. Got my point? Now if I write basic code, so you guys will understand, like, first, again, just how binary search is. uh, we will iterate it as row is less than n till row is less than n, and column is greater than equal to 4, sorry, equal to 0. Fine. Now if matrix row column is equal to target, return uh, return row call. People who are doing Java, I mean, like C++ code is kind of equivalent to this only, but Java, they have to, look out for the syntaxes. Again, I, like, from the first class only, I heard that many people here prefer C++, and I am comfortable with Java, to be honest. So, but I wanted this course to be more of, generic, like, for comfortable for both of them, for both of the users, right? So what I'm doing is, like, I'm just writing the pseudocode, and you guys have to go out and see how to exactly code with the syntaxes, right? Because here, and again, in this course, we'll focus more on the problem solving approach, right? We will, like, if I give you multiple questions, if I solve multiple questions and just leave, you guys can do those multiple questions, but will you able to do all other questions? No, right? Because I haven't exactly taught you the mindset, how to think and all. That's why this in this course we will be, like, approaching in this manner. But again, if you guys have any problem with the codes, please let us know in the Telegram channel. We will provide you, and maybe in the next class I can, take up that code and explain that as well. Fine. That can be the flexible way. Fine. So again, matrix of row, exactly like how binary search works. If the target is less, else if, then you can do the row plus plus, because here we are seeing that, right? If the matrix and row is less than column, whenever the target is less, what we are doing, we are increasing the column, right? Increasing the column, and whenever vice versa is happening, we are decreasing the column, right? Yeah, so this is what we will follow here only, right? Else, again, now the last question, last condition, else column minus minus. Fine. This is an if you don't find any element, just return -1 and -1. Uh, got this approach now. So again, this will be of log. Can someone tell the time complexity of this one? It's not exactly uh, binary search, because we are not, I mean, if you think that it's halving, it's not exactly halving the elements, but we are discarding halves, right? We are discarding rows and columns. But again, this is not a exactly not a binary search, but again, I just wanted to take up this example. But now, yeah, can someone tell the time complexity of this matrix, of this question, of this code? We are iterating through n, right? N is the number of rows. Also we are considering m, so n plus m, here it will be n plus m, which will be ultimately o of n, or you guys can say of m, because it doesn't matter, we discussed the rules of time complexity as well, right? Anyone, is anyone having any problem in this code or anything? They can unmute themselves and
Bro,
yeah.
bro, can you please explain how are we eliminating the row elements? I can understand how are we eliminating the column, but I can't get how are we eliminating the row element.
Okay, okay, that's fine. So, like we can see that I can just erase it here. Yeah. So, whenever we're seeing that the element is that the target is 14, right, and we are at 12. Whenever we are seeing that okay, this doesn't works for us, like why, when are we iterating the column, sorry, when we are going to the next row, when we find that the target is less, the target is more than the current at which we have are, right, then only we are, whenever we are, I'm saying discard this and consider this, so we are kind of iterating through the row, right? See, basically what we are doing is that, let's say we are at 12. Fine. Let's say we are at 12. And we see we need to find one target element which is more than 12, which is more than the current element which we are standing at, which is 12, right? What we are doing that in that case, we are saying that it is the target is more than 12, so it can't exist in this row, right? So we are kind of seeing that if the point at which I'm standing right now, it is less than the target, iterate it, go to the next row, go to the next row, right? This is, and in this code as well, you can see I have written if the row is less than target, then that's fine, then go to the next column. Else, if the matrix row is more than the column, again this row and column is actually where we are standing at the current point. If it is more than the target, go to the next. Okay, I just said in reverse. Yeah, so this is the only condition which we defined, right? If the it is less than target, if at point we are standing at 12, we need to find 14. If it is less than 14, which it is, go to the next row. That's what we written. That's what we wrote, right? And I also discussed that point as well. I was using this column pointer, but again, here also the row pointer will be here, and it will iterate like in this fashion only. Got my question? Like when we got here, I guess I didn't move this row pointer, but now like you guys can understand now that with this column pointer, row pointer was moving as well. Got my question? Got my point? Did you
Yes,
get, yeah, yeah. Did you get the, yeah. So just consider, just see, just whenever you're finding some problem with the code, just go, just take this example and try run this code. Like just how I did, like let's stand at 15, then go to 12. Okay, 12, we have to find 14. 12 is smaller than 14, so we can discard this. Basically what we are doing is we are discarding this search space, which means that we are kind of moving the pointer to the next row. That's why we are iterating. Same for column, we are going to the next column. I mean, we are decreasing the column as in we are going back, right? Hence we are writing column minus minus whenever we are finding our current element to be smaller, to be more than the target, right? You getting my point now? So just again, this is your homework, right? Like just go again. You need to like practice again, write the whole syntax in your own preferred language. This is again your homework to apply this code. Like this is just a pseudo code. In the last question I gave the code, but in this is a pseudo code. It's not properly written. Apply this code and run it. I mean, this is just a homework for you guys. Fine. Like I just made you understand this approach, right? And this is all the test cases you guys can find. It's not more than this. This is the approach only. So yeah, just go and apply this code, right? I have done the most work, but yeah, you guys need to go and um apply this thing, which apply this approach. Fine. So because this is how we will learn, like going to the compiler and coding out solutions on your own, right? at first I will be providing you approaches and you will apply it. After some time, I will be just telling you the questions. I mean, obviously I will discuss and all, but you guys should be trained enough that if you see the question, if I tell that these are the sample test cases and this is the things you need to handle, then you can directly use your own approach, code out at on your own self. So yeah, from like that will be our target, like to make you guys train in that way only. That will be my target and everyone's target. Fine. So this is the 2D right now. We will give you two. I mean, in 2D matrix for an interview, like with interview experience, interview point of view, 2D actually comes fine. They won't tell you to code out the whole solution and all, but again if you tell them this approach and all, that would be fine. But again the 2D comes in online assessment rounds, right? The coding rounds which you guys have the time limit of 1 hour, their 2D comes sometimes. So you need to perform, you need to practice this 2D, and we will be giving you 2D patterns again. Fine. Yeah, so that, so 2D, I guess. One question you guys can practice again.
I was getting a little bit confused with the time complexity part, because in the binary search there are two three questions which have different time complexity. So could you explain that part again? Because
Yeah,
one was
yeah,
just nm, one was just n plus, one was n plus m like this one. So how do you decide whether it is nm or n plus m?
yeah. So the questions which I gave you guys to practice, or what?
Like the one you solved now, it was n plus m. You have written it there, but the previous one, like the brute force method you did, that was nm in the first in the beginning. So how, I'm getting confused. How
Okay,
do
the
you
time
decide
complexity
what should
part.
be the
Okay,
time complexity?
yeah. Please, yeah. Thank you. Yeah, just I will tell you that. So O of n cross n, right? Okay, okay. So in this, in you are saying in this brute force method, right? This is the brute force method which we discussed.
Yeah.
Basically,
How do you decide it?
yeah. Basically, so let's say that we have some the numbers, right? We need to iterate through it, so we get the O of n, right? In the 2D matrix, right, in this brute force method, what we exactly doing is that we were iterating through this, right? Every this also simultaneously we are iterating through every column as well. So you guys, can you see this is happening like overlapping? I mean, in 2D matrix, we are iterating through every element, row wise and column wise. That was making it O of n cross m. Fine. Right now, for now, just understand this. Fine. Now here, we are, first of all, we are discarding a lot of, wait. Yeah. So first of all, we are discarding a lot of, rows and columns first. Fine. Our row pointer was here, our column pointer was here. Fine. And here you can see we have used this while loop, which actually is for loop. I mean, we are iterating through row n and column is 1. So basically we are iterating through this thing, right? This thing. And also like I mean we are iterating through this one, we are checking every element, right, in this manner, but we are updating our pointer to here, right, and updating to this. So basically we are minimizing the space. So kind of we are iterating through arrays elements only, but we are minimizing the space, right? So here we are not cross checking every element, we are minimizing the space. And when I say O of n plus m, here, M actually means anything. I mean, in the time complexity, I think you attended the first class. When I say NM, it can mean anything. NM means that the worst case scenario, right? N means the worst case scenario. If this matrix was infinite cross infinite, right? That would have mean some part is subtracted and we have still this thing. So infinite, from infinite we are subtracting some infinite, which means infinite only, right? So kind of we are uh, adding them only, right? We are not cross checking every element again, we are not going through every element again. That's why we can't write O of n cross n. We have to write n plus m, because we are we are getting a new column, and we are n is here as a row, and m is column, right? So we are, subtracting the spaces, and we are, iterating through column and row differently. That's why we are writing O of n plus m, right? I mean, I don't know if you got this exactly, but just understand for now that n cross n comes when we are, going to every element again and again. Like, I mean, simultaneously we are going to again and again. But here we are just subtracting the search spaces, right? So we can say it is kind of n plus m only. You got the point?
What
I mean,
about when it's log m?
it is not log m. It is not log m. It is not binary search. No, it is not exactly. We are not halving the. See, log m actually came from 2 to power k, right? 2 to power k is equal to m, right? From there only, actually, it
Hmm.
like log m exactly comes when we are halving the arrays, right? But here we are not exactly halving the arrays.
Yeah, yeah.
Yeah, we are just, minimizing the search space, right? It is kind of binary search. Again, I told that earlier as well. It is kind of like binary search, but no, it is not binary search. We are just kind of subtracting the part of it, right? So
Okay.
yeah, so we can't, it's O of n plus m only. Fine. I don't know, like, many people may still have that confusion that again we are kind of, subtracting the halves only. This can be binary search. Uh, I mean, I don't feel that this is a binary search, because binary search has some strict coefficients. Maybe people will see the sorted array and think that, okay, this is a binary search, but no, I don't think so. Like, it is not, because even time complexity is like this. So I guess you guys can, this approach, you guys can, go, and I mean, in your free time, you can see, you can check if this considered as BS, and let me know, and come up with your explanation, and let me know that how this is binary search, how you guys feel that it is binary search. If not, then yeah, just go ahead with this thing. Fine. So yeah, I guess that's done till now. Any more questions? Because then we have strings. We need to start strings then. And yeah, we will just do strings again. I got to know that the pace is very. I mean, you guys feel that the pace is kind of fast. So hence, I will be doing topics like slowly and slowly, so that no one feels overwhelmed with this course. Fine, because that's not what I want. I don't want to do questions and questions and just leave you guys with nothing. I want to give you that approach. I want to give you that thinking capability to solve these kind of questions. Right now, in the homework, we'll give you one problem, which will be finding a peak element in 2D. Now this question you will be able to do if you have done the 1D ka homework, right? The questions which we gave for the last class for the 1D thing, 1D BS and 1D. Using that, you guys can do this thing. So again, I'm again reminding you guys, please start practicing whatever we are giving you questions, so that you guys don't, lag behind this thing. Now again, this peak element you guys will able to do only if you have done the 1D thing, right? So in this manner only you guys will get assignments. So again, and if you guys don't understand any kind of question, please let us know in the Telegram channel itself. Fine, you guys can you guys can, message anything, queries, any help, any new thing or new method you found, or any, I mean, any mistake which I did, you guys can point out in Telegram channel only. Fine. So yeah, so can we have a break of, let's say, 5 minutes, and then we can start strings? Will that be fine for everyone? 5 minutes
Yeah,
break?
fine.
Yeah, okay, so fine. So we will be meeting after 5 minutes. Fine. So yeah, 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 recording is resumed. Yeah, so before starting strings, let's play some games. Fine. Have you guys, has anyone played Scribble here?
Yes.
Yeah, so like just it's just I will just have this 3 round thing. So I will just give you guys the link. You guys can join, right? I just want you to guys fresh up. Yeah. So just join quickly. Everyone join and let's play this game, right? We can play this game. I'm just like we will deal with strings here. So and this is just a 3 round game. So let's see. I mean, who wins? Can I increase round? I don't know. 80 into 3. It will take some minutes. Okay, let's keep it 4. Okay, I have to stop presenting also, right? Because you guys will see then. Wait, wait, wait. I'm stopping the presentation right now. Let's play the game. I think I will have 4 rounds only, right? Has anyone joined? Yeah, let's start. So Tanisha is choosing. Fine, fine. I'm not presenting right now. Okay, fine. Yeah, just this. Hmm. It's not Angel. Oh, it is. Nice. How much time I gave? There are 4 rounds. Okay. I hope this doesn't take more time. I guess I can cover strings in an hour, so yeah, it will be fine. Then for string. It's not cigarette.
I'm too bad at drawing.
It's fine, bro. Just
And
give us
my
hint.
whole screen was occupied with ads, so
Give
I
us
can't
hint.
do.
Give us hint. Like no one can understand this, I guess. Give us hints, bro. Not
Uh, I
cigarette
mean,
or
my whole screen was occupied with ads.
is it blunt?
It's
No,
related to food.
it's related to food. What the hell? Uh,
No.
no. Draw again. I guess. You know that if you don't guess, you will also lose points, right? It's not always that.
Yeah, I guess that.
Okay, people are guessing. I don't know how. What the hell? Sausage. Oh God, I got it. It's fine. Good, good.
Sorry,
This is
sorry.
not a sausage though, but okay. You guys can use colors as well. It will be down, I guess, somewhere. Form the strings. Find the missing strings. What is this? What's happening? What? Yeah, not exactly that, but okay. Wait, round one. It's still round one. Okay, we will end this when this round gets over. Fine, because we can't take much more time. I thought there will be 4 rounds, as in 4 people will choose, but no, it's not like that. Yeah, so yeah, round. How many people are there? Okay, 8 people. I guess we can cover this. What is this? What? What? Oh, nice, nice. This television. What? Yeah. Pawan, your string has a null character between YouTube. There's no null. This is continuous string. I'm recording the game as well. This will go in the video. Anyways, is the round one over? When will the round one get over? Jeff. Damn. Yeah, I think this is the last one.
I'm sorry, I'm very bad at mine.
Oh, you came again. Caterpillar.
It is a giraffe.
Okay, on this note, let's just end this thing. This this can't be done again now. Yeah, just this is the last thing. Giraffe. Fine, fine. Leave, guys, leave. We have to study now. Leave. Yeah. I guess I guess who got the okay, I guess wait, let me see the name. I think this girl got the highest points. Parnika got the highest points. Congrats, Parnika. You have cleared the scribble round, but still strings round is left. So let's study strings now. Right. So wait, let me share my screen also. Forgot to share the screen. Yeah, is my screen visible? We will quickly start strings now. So the reason I played that game was not just about your enjoyment, but also just to, where we were guessing the words, right? So that exactly what a string is, right? So I mean words, and we were guessing is my screen visible by the way?
Yes.
Yeah,
Yeah,
visible.
okay. So we were guessing the words and all that, right? So that's exactly what a string is. But you guys might have heard something also, or maybe not, but something called as char array, character array or char array. Does anyone know the difference between strings and char array? If not, it's fine. I will explain you guys. So before jumping into strings, we will discuss about what exactly char array is. Fine. So now, if I write char a is equal to z, right? Char a is equal to z. What exactly that this means? That a, like there's some character a which has value z, right? But it's a character, which means that we have one block which says that z, and it is actually a, right? So right now if we use a char array to define, right? Let's say that we have this. Now we have char array as something as um, tech shots. TechShots, many guys don't know that TechShots is actually my your Instagram channel. You guys can follow my TechShots channel as well. TechShots at 60 on Insta. Fine. I make the reels related to development, web dev, and DSA. Right. So when I say char array, how this TechShots is stored there? It's stored like this. Like there's T, there's E. Oh wait, what happened? There's E, there's C, H. Okay, wait. O, T, S. Just quickly do this because I don't want to take much time on this thing. Yeah. So T, S. So basically, what char array is exactly is that it's just an character array, which means that if I push this, it's actually not defined in this manner. It's actually like this char array, sorry, my bad. So when I say this, it is stored in this way, like it forms a character array, and each element will have each character, right? So this is basically what character array is. Fine. Now also in character array there's one more thing. There's a null character there, which means that which tells the compiler or compiler that the char array has been ended, right? So whenever we define as like whenever we are defining a char array, right, of let's say 5, right, or nothing, or 5, and we have not assigned any value to it, it will have one array, and inside that there will be just one null character, right? This null character. Now this doesn't happen in the strings, but char array it happens in this way. Fine. So this is what char array exactly is. Now let's say that we have we have defined something as char name, right? Char name 10. Fine. Char name 10. And I have said that this char name should contain this text shots. Fine. Text short. So in this, so like at the end, so it will be indexed, right? 0, 1, 2, 3, 4, 5. Text. Okay, I messed up the spelling a bit. Hold on, guys. Wow, my own channel I messed up. Just hold on. Text shots. SHOTS. I should have done this earlier, but okay. Tech shot. Fine. It's H. Yeah, cool. So this is how the text shots will be stored in the character array. But this will have a null character as well. Fine. So the indexing would be in this manner. It's taking much more time, but okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Fine. So the last will contain the null character, right? So that we know this when the string when the this character array ends, right? So if you put the null character, it will uh, it will stop the traversing or any kind of operation basically. Like let's say that we need to print this. Print out whatever is stored in this I mean character array. So how you can make the program stop? Can anyone tell? Like how can we make this to print? Like let's say that this is 100, right? So if we need to print text shots only, we don't need to iterate through all the elements, right? So how can you make it stop till the last ends, the content ends? Can someone tell just by just uh, telling how what can be the condition of the, let's say we have, okay, one more hint. Let's say we have one pointer there, right? We have defined one pointer count, right? So how can we tell that to it to stop that and print whatever they have it has iterated?
We will increase the counter,
Yeah, yeah.
and when the character
Counter.
will be S,
When
then it
the
will make.
no, not S exactly. When the count gets to null character, it will stop. Basically in character array, every content whatever is stored, at the end there is a null character, right? So that's the indication. This is what it tells. It actually tells, it tells to it tells to stop traversing. I mean, it tells the ending of the array. It tells the ending of the data store. Fine. So this is what the significance of null here is, right? Now, let's now also one point to be noted that in strings, like there might be people, again this comes like there might be people who are in C++ plus plus or in Java, right? So I will be like after like in this class only, strings is actually kind of language specific, as in like in C++ plus plus there are some different things you need to do. In Java there are some different things you need to do. So I will try to tell you both the things which needs to be considered, but again at the end it's your job to apply everything which I tell today, and apply that algorithm in your own language in any one of the compilers or anyone or any question which we give to you. Fine. So first of all, for now, let's see how we can calculate the length of uh, char array, right? So so yeah, can someone tell like how can we, if this is not given, if this is not defined, the size is not defined, and we have entered a text shots, right? So how can we find the length of this character if of this array.
Dot length method in Java.
Yeah, dot length method. Yeah, without using the inbuilt functions. I mean, this doesn't comes again. I mean, it's just a part of curriculum. So yeah, that's correct. Actually, dot length again. I told you guys that dot length is used in Java, and C++ it is something different. So yeah. So in I mean, just finding out the length of the character. What you can do is I will just write the small
L-
codes
Looping the whole array and
exactly, and
increasing the count variable.
yeah, yeah, correct. Yeah, so we can define C is equal to 0. And as someone said that we can uh, loop through the whole array. And if uh, we can loop through all array, and if the name at I is like, if the pointer encounters a null character, we define it like in this manner. If the counter defines uh, null character, keep increasing the pointer and return C. Got this? Sorry, this is negative, not equal to. I mean, like keep increasing the pointer till the null character is not there. If the null character is encountered, return C. Like stop this program, this for loop and return C. Is that fine? It's very direct way to find the length of character array. Or you can use again, you can use the dot length method. Fine. So that's the thing. Right. So again, now coming to reversing a string. Now, how will you reverse a char array? Not string. We will go to string afterwards. But how you will is reverse a char array? Let's say that. Okay, I will tell. Let's say that we have. Yeah, someone was saying. Please, word.
We will iterate from the last position
Hmm.
and store the elements in a new array. So
Yeah.
complexity will increase, I think,
Yeah,
as
yeah,
we
exactly,
iterate in new
exactly,
array.
exactly. That's a correct. I mean, that's a good way as well. Tech TCHSOT. Yeah. So basically, if we give input as tech shots, we need to get this. And someone said that we can, what we can, store them in an array, right? And then just uh, क्या like just output this array in a reverse manner, and we can get this a thing. Again, that's really good approach. Like someone just I mean told this approach of their own. Again, it's not it's in an interview, like you can start with this approach, right? So this is a correct way to like first start, and then the interviewer will himself or herself will say that to make it more efficient. Now you can use now you can make this more efficient by using something called as a swap function, right? So basically what we will do here. Oh, someone joined right now. Okay. If you join late, you will get the recording. Fine, you can see the previous thing which we covered. Fine. So we can use swap method. So basically, what will be the approach? I will tell you. See, let's say that we have tech shots. Oh, tech shots. Fine. Now my approach is not iterating through the whole thing, or make it will first of all this will be O of n. Fine. O of n, uh, and also we are maybe again making it like again we are traversing, so O of n plus n, which will be ultimately O of n. Fine, that's fine, but the space complexity would be more, because we are making one more array, right? So this will increase the space complexity as well. So hence, to make it more efficient, what I can do is I can first make it like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Just hold on. Yeah. So you can see that this is an array, right? What we can do here is that let's let's divide this array, right? Fine, we can divide this array from the middle, and we have to reverse it, right? So can we do something to reverse this, and then reverse this reverse this second element to the second last, and then first element to the last element? Can we do this approach? And for reversing them, we can use a swap. We can use a swap function, right? So this is some kind of different approach here. Can Does anyone want to say something?
We can use two
Maybe,
pointer.
We
yeah,
can
two
use,
pointer.
yeah, obviously. I'm just like, again, in an interview, you don't directly jump to the most optimized one, right? That's why,
Yes,
like, the
yes.
first approach he told, that's correct one. Then we can use this approach. Then you can use also a two pointer method as well. Fine, that's also a better method. You can use swap function here. This will be O of n, and that if you use two pointer method, that's also a most efficient way. Fine. So I will say that if you know the two pointer method, that's your homework to code it out, because again, this is kind of like a uh, basic array question only, because we are just reversing them. It just happens to be a char, right? So character array is like that only. So homework, if this is your homework, this actually you should do that. Code code to reverse a char array uh, in most efficient way. Whatever you think is the most efficient way, do it. Fine, most efficient way, do it. Okay, now coming to now this strings question, this string part. What I'm doing here is that I'm focusing more on strings values, strings concepts and all, which I will cover later on as well when we are doing it with respect to CPP and Java, right? Abhi we are just doing char array, right? So what happens in strings question is that most of the strings questions have, like, here we will mostly do the sliding question, the sliding window. We will use sliding window afterwards. Fine. uh, Most of the time these types of questions are solved with hash maps, or sometimes you will find out you will use priority queues, you will use stacks, right? So these data structures we will cover later on. Hence I will be doing questions with respect to whatever we have learned till now, right? I can't, like, if one there's one question of balancing brackets, right? That can be done. It's a string based question, right? That can be done in priority queue, right? Sorry, that can be done in stacks, but I can't explain that in a stack way, right? So I won't be covering those questions. So basically we are not completing strings today. We are just doing the concepts of strings. Again, afterwards, when we are doing priority queue, when we are discussing strings, when we are discussing stacks, there the string will come, right? And then you will need to know the basics of strings and all, which we are doing right now. Fine. So again, now the second question which you guys should know is how to palindrome a string. Is anyone not familiar with the palindrome? I guess everyone is familiar with the palindrome, right? Yeah. So it's basic stuff, right? Like if there's S, if we have one string, let's say ABCBA, right? We need to reverse. We need to basically, and the reverse of this is also ABCBA, right? So this is palindrome. The S is palindrome. Hence, we need to return true. How will you do this? Uh, uh, is anyone having any kind of solution for this thing? We need to just return true or false if this is a palindrome or not. Like the first approach, not the most efficient way. Again, the first approach which you will think. First approach can be using the reverse thing. See. First approach can be we have one S. We use reverse function from top, we get reverse. Then what we can do? We can just compare them. If any string ka reverse is equal, like the strings, the reverse of a string is equal to the original string. This means that it's a palindrome, right? So that will be the first approach. But for the first approach, we have to reverse it and do another operation, right? So to make it more efficient, what we can do? Can someone now tell the second approach, which is kind of more efficient way? Let's say that we have,
Recursion.
yeah, we can use recursion.
That swapping technique which you have told earlier,
Yeah, we can use
we
that.
will check
Yeah,
the first and last element and
exactly, exactly.
move the pointer
Move the pointer.
on both
Yeah.
sides.
Yeah. So here, if we have this, let's say that we have, for those who didn't get the point, if we have uh, starting and end, let's say, fine, we have starting and end, and so we can just, compare both the elements, and if the elements are same, wait, wait. I will just start from this approach. If the elements are same, A and A, then iterate like do S plus plus and E minus minus. If again you can check B are same, do again S plus plus E minus minus. Now again S check, it is same. Then again do E minus minus S plus plus. But we will have a while condition which will check that S should always be greater than E. Hence, when these pointer crosses, which means that to end the loop and return true. Got the question? Got the approach of this thing? The second approach. Can anyone code this? Now, like, okay, I will just give you some hint. Like, while we need to start with the while loop, right? Because we have to run the loop till the S and E are, S is greater than E, right? So while S is greater than E, we can have S starting S string of S is equal to str. For now, just see that string is just a char array. Fine. I will explain this is just a char array. Fine. So I'm just calling it string because it is written as str. Fine. It's just a char array. So while S is not equal to STRE, fine, return 0. Then and else S plus plus and E minus minus, return true. If this loop ends, return true. Is anyone having any doubt in this part?
Yes, S
What?
greater than E in the while condition. I couldn't understand it.
While condition. Okay, wait. See. I will tell you.
S greater than E.
S greater than E, how? Okay. So when we are iterating through, so first we define S and E, right? That's easy. You guys can define that. Now when S and E, like we have to start, we need to keep the while loop running till S is greater than E, right? I told you that when they come here and when it crosses, like C is equal to SE, right? It crosses this here, E becomes more than S, right? str of E becomes more than S, right? So kind of you guys can think that when this crosses it, it will stop the loop, which means that the string is itself palindrome. You got the point? How why we are writing S is greater than E? Are you getting the point or not?
Starting index is always smaller than the end index.
We are not basically while S is not. We are not comparing the indexes again. We are just seeing that if S pointer is like ahead of E or not. Like it should be always greater than S, right? So that's why we are not comparing indexes. We can see S and E, right? In the string manner, it is not in that way. We are not comparing strings. We are just checking if S does not crosses E, right? If it crosses that, it means it is palindrome, right? So that's the only thing. It's easy, not much.
Okay.
There return 0. Yeah, I guess that's fine. This is the second approach. Now we will discuss what exactly string is.
Uh, Sorry to like interrupt. He actually, can we go to the like? So it will never go into the loop, right? Because for example, S is zero, and E is, for example, 0, 1, 2, 3, 4. Okay, so zero greater than 4, so it will like not like
Wait,
it will not be.
let me define this.
Uh,
Fine, we can have s is equal to 0 and e is equal to n minus 1. Okay, we are seeing that while s is, I mean, it's basically what it's doing is that uh, s should be, when s becomes greater than e, it should run out of this loop. Got the point, I guess.
Yeah.
So S is smaller than E, right? So this is running, and when
No,
S
but
becomes greater than E, it
No,
will
he's saying that in the while loop, it should be when s is less than e, then only it will run, right?
yeah.
So
when
so
the
when s becomes greater than e,
Oh
doesn't mean
yeah,
the
oh
while loop
yeah, sorry,
should run.
sorry, my bad. Yeah, yeah, yeah. Oh, I did. Yeah, I did. My bad. I was seeing this view, right? It should be S is while S is smaller than E. Yeah, sorry. Yeah, thank you for pointing that. Yeah, so sorry. So while S is smaller than E, yeah, that's correct because the loop it will enter the loop when S is smaller than E, right? Am I right? Yeah. Is it the point you guys are trying to do, right?
Won't it be S is less than or equal to E?
Yeah, you can end. Yeah, you can write equal to E. Yeah, yeah, that's more better way. S is equal to E, but here string is then it's fine. Yeah, it should be equal smaller than or equal to E because in this condition it is becoming equal, and we need to check if I mean it's just a base condition that I mean obviously the S and E pointer if it's pointing to the same if it is equal then it will be equal, right? The palindrome happens to be the middle element happens to be uh, the same thing, right? So yeah, we can I mean it's not required, but yeah, just to see the base cases we can add this equal to as well. Yeah, so sorry that I got confused in between only because I wrote this thing. So yeah, while S is smaller than E, then only this while loop will run and S plus plus E minus 1 will happen. Does anyone have any doubt in this now? I guess yeah, I think not, right?
No, no, everything is
Yeah,
fine.
yeah, everything's fine now, right? Yeah, so yeah, my bad. I just I
No
wrote
problem,
it.
happens, happens.
Yeah, it really happened. I wrote it as is equal to E because I thought it's an string one. So yeah, now we can start with strings. Fine. Till now we were doing char array, but you know character and strings are more or less same only. There's only one factor which is different in strings that when we are defining, let's say that we have defined string s and we have written string uh, we have written okay, let's say that we have written s as text shots. Wow, text shots. Fine. uh Here the element here there won't be any null character, right? If we are defining only string like s, it will just be an empty array but with some garbage values. Fine. So there only we can this is the only difference which we know right now. You guys can this can also be your homework just to see that what is the main difference between char array character versus strings. You guys can maybe this is also good homework for you guys just to see just to compare what is which is what which thing is doing what. Fine. Yeah, so as someone said that for length again if we are using strings, right, for length we can use things like str dot length to find the length of the particular string. And again now I will do one more thing. I will divide this into halves. This will be for cpp people, and this will be for java people. Fine. So yeah, so for finding out the length of a string, we can in CPP what happens, we can directly make it to this, right? In Java, what happens that we deal with something called as string builders, right? I will for this I think this needs a bit of understanding, but this course is not focusing on a particular language, right? So what I will do is that I will give you one video which is like based on string builders only. Fine. Related to Java, so you guys can understand it more clearly because in CPP it's pretty much direct because they are built in libraries and functions. In Java, we need to build something as string builder, and then I can just give you just about it. Let's say that we have some string builder, and we are defining one string builder. We need to define it as an object buildr, and we can say text shots here. This will create, wait, this will create a new, string using the string builder, and this str, which basically means that you can put str here. Fine, now you'll understand it, right? So this is the thing. And also, whenever you need to, when you are dealing with strings in Java, you always have to, uh, let's say that you need to convert it to a char array, char character character array string, right? So let's say that I think this I will provide you one video. From there only, I guess you can understand it more clearly, because that video will just cover how string builder works and how many built-in functions are there in string builders, right? I will just tell here that how many, like the comparison between these two. Let's say that now if you need to, if there's a one string and you need to push something. Let's say that we have this text shots. Let's say that we have text shots here, right? And we need to push some character, let's say C, right, here. So in CPP, what we can do is we can use some this function push back and C, this. Yeah, this will make it to, push it to any, the string str. If the str is text shots, if we do str dot pushback C, it will, make the new modified string. Fine. And if you need to delete it, if you need to delete the C, you can, what you can do is you can just pop. It's like stack. Again, it's like a stack. If when we will do the stack, you will know how the push pop is happening. But yeah, so this is how it will work. Now if we do this, it will pop up. Similarly in Java, we have something called as string builder. For pushing back, we can use something called as append C, append C, right? And for deleting any character, and using string builders, you can delete any character. So we can use string builder, not actually string builder, but str, because we have defined string to be str, right? So we will write string str dot delete char ar, delete char at. You can define the length, uh, length minus one. Whatever. If you want to, delete the last element, you can just use the length, and you can just use the n minus one, which means that it will just delete the last element. Fine, last element of the string. Fine. So this is the comparison between CPP and Java. There are many other functions, but again, for Java people, I will give you one video which will cover like everything related to string builders. And also, coming to next point, if you guys need to, like master any kind of language, you guys can go to some with this website. I call exorcism. This website. So basically, this website, I found it very actually really great, because this has something as many kinds of language. You guys can, like 67 language tracks are there. Like I was reading, I was doing, like I'm doing my internship in full stack, right? So there I had to learn this language, Elixir. Fine, it's a language for it's used in, actually used in backend, right? Linux and all. So there, if you need to learn any kind of language, let's say that in your case, you guys are finding difficulty in, relating to any kind of language which I'm using in the video, you guys can go through this. Let's say that you guys need to do Java. You can search for the Java, and there you can join the tracks, you can explore the concepts, and there you will find a lot of, like the questions just based on the Java principles, not the DSA part. It's just the Java principles, right? Maybe later on you will find some questions as well, like constructors. We have constructors here, inheritance, enums, method overloading, right? So it is more of a language specific practice if you guys need to do it more. So I will just provide the link to this exorcism website. There are many other languages. If you guys are doing any kind of other tech like web dev, Android dev, or any kind of other things, let's say MLAI or something, you guys can, see this, check out this website. And like, it's not some promotion or something. I really found this website great. That's why I'm telling you guys, right? Because you guys might have problems with the CPP, Java, confusion and all, right? And I'll be using here pseudo codes, and mostly will be focusing on how to solve the problem rather than just coding, right? So yeah, uh, coming to the next part. Let's see what we can do next. uh, till then you guys can go to that website and check out what other languages are there, and how you can sign up and all. It's free, again, it's free of cost, nothing. uh, till then I will just write another question which I will discuss. Okay, I think we can do this question. So question is that we need to, like, from a string we need to return maximum occurrence of a character. Fine. Uh, I'll give you one example. Let's say that we have some string called test. Fine. Now, there's like, we can have T E S, right? So how many times T is coming in this string,
2 times.
and E is coming one time, yeah, S is
One.
coming one. So we just need to return the maximum occurrence, maximum times T is coming, right? Two. So we need to return T here. This is the basic question. You guys can take a minute and think what we can do here. Uh, and unmute yourself and tell what you guys are thinking right now. So one approach can be that, let's say that we have some kind of um, like we define one, maybe array, right? We define one array where the array is from A, B, C to Z, right? Like 26 size of array, and we see T. Okay, we, and there every value here is null, right? And we see T, right? So we, like, here comes the T and we will increment it to 1, right? And E comes, E will be here, we will increment to 1. S will be somewhat here, 1, and T will increment to 2. Now then we will, uh, iterate through this array and see which has the most value, right? And this will be 2, right? This can be one approach, but again, this takes a lot of time and space, right? So this is not a most efficient way. We have to think something else. So what can you guys think? I will for this question, I will start, like, I will explain by coding only, because this needs uh, little bit of understanding, right? So let's say that we have some char function which will return which will return you an character only. So I have defined it like this. and we are inputting one string s. Fine, we are inputting one string s. Right now, what I can do is that, okay, there are many constraints for this, right? Like let's say that it is kind of case sensitive, right? So what I can do is that for lower case, I can define this as just hold on, let me think how can I explain this to you guys. Mm, okay, so there's something. Are you guys aware of the ASCII values? Or we can have another method. I'm not recalling it right now, but like lowercase, there can be, okay, so this question, we will have the lowercase and the uppercase values, right? So here, uh, basically what we will do is that we can have one string. Okay, I will just start the coding and then we'll explain you. Fine. So first we will define one character, right? It will it will basically, it will, iterate through the string. Fine. And int n is equal to 0. This is just for reference. Now if ch is greater than equal to a, small a, right? Right now just see the code, I will explain you later on. Fine. This will be z. If the ch is kinda like in between, then uh, just hold on. There's something wrong with this thing. Yeah. So
Looping the string.
yeah, we are looping the string, right? So here I have defined n, right? So n will be minus a if the basically if. So what I am doing, I will just explain it later on. Just focus on this code for now. I'll explain. Don't worry. I will explain. Don't worry. Uh, Array of n plus plus. Fine. So basically in this thing we are like when a character, I mean let's say that we have this test. Fine, test, T-E-S-T. We have this test. We are defining one ch and we are iterating through the character array, right? So we are just for now we are checking if ch exists between a and z. So basically in in a program, in any kind of compiler or something, there might be some values. If you guys are aware of ASCII values, you might have understood, but okay, if you guys are not aware of ASCII values, it's nothing wrong. So there might be some a to z somewhere stored between somewhere stored in memory, and then there also be something stored with between a and z, right? A and z. Fine. So with this condition, we are just checking if like this problem deals with this should be case sensitive. Let's say that let's say that if it is t, right? So the small t and big T can't be equal, right? So in this case, it will return one only because everyone has the one occurrence, right? So that's why this question is case sensitive. That's why ch will be that's why we are just checking if the ch is smaller or greater by just looking if the character is between them. And what is n doing? N basically what it does is that it just increases the array here, right? Here also we are defining one kind of array. I think this problem is again in is not if efficient enough, but again I know I know the problem how to solve this using hash maps. Right, so basically in hash maps we uh, insert these values and we just increase the counter and just return whatever data value is increased, right? So hence that's the most efficient way. That's why I was saying in the strings question, let's just focus on what exactly, how exactly strings works, because every question which we are doing right now, it has more efficient solution in the upcoming data structure. That's why we will just do the inefficient ones for now. Fine. So I guess you guys can then, this is just a thing which I am using for case sensitive, for just sorting out the cases, right? And n is just something which you guys can, use to fill this array up. This thing which I have written in my notes, it's actually exactly the same thing. Uh, like let's say that there's a small character and t comes here, and you can, one, you can add it to one, then again t comes, you can add it to two, then again you need to, iterate through this whole array and take out the maximum element for this, right? So this again is this is the same solution. I thought I was doing the different one, but no, the different one is using the hash maps, which we will cover later on, right? So this will be your homework, I guess, because this is the inefficient one. So you need to just complete this. I just gave you one case sensitive approach, right? So I will provide this question link, and I will give you in the telegram itself. Fine. So for now, just understand how the strings are working. Is again, we will discuss more efficient way in the hash maps, in the upcoming hash maps, not now. So just just do it by your own self for now, right? So this will be again your homework for now, right? uh, you need to just handle case sensitive cases. I explained you that, right? So just handle that. We can do the another question, which is more of, which is more of dealing with strings and more of world, like kind of real world example, right? So like for now this question is kind of little bit invalid right now, because we will discuss more efficient way. Fine. Do this by your own. We will provide you the link, problem link. Coming to the next question, have you guys seen the websites which has like, let's say that I have entered hi hello. So can you okay, you guys can't see the this space, right? Okay. So whenever we are dealing with URLs, right? So like let's say this, I have written hi hello in the Google console. So what actually happens in the link? It inserts this hi hello 20. It inserts automatically this thing in the website URL. Like it just sees the spaces in the Google which I provide, and automatically provides this thing, which you will understand when you are doing the computer networks, when you are learning the computer networks in your college or anywhere. You guys can, like look up also, like why this percentage 20 is inserted here. Fine. So so yeah, this is the only question, that let's say that we are given an string which is like hi hello, or my name, hi hi TechShots. Fine. So basically here it will just like the string starts from here again. So you can't enter percentage 20 here. You just need to enter it here, like percentage 20 here. So in a string, given string, you need to replace the spacing with the percentage 20. So what can be the brute force method for this for now? I guess you guys can explain that. Hello, am I audible?
Yes, yes, audible.
Yeah, so like the previous thing which we like discussed in the CPP, right? We use something called as pushback, right? So what we can do here is that, let's say that we have one string given, um, we are given one string, right? And we can make another temporary string, fine, and iterating through istr dot length, because this is the function we are using. Again, this is for like we can use inbuilt functions in the interview as well. right? So you guys don't have to worry about that. So if the string of I has, if you guys have encountered a space, then just temp dot push back, where at the I, because it is in the condition, but what you have to push back at the rate first. You can't in the pushback, you just need to, you like in even in the append function, I think I'm not sure, but in the append function also you can push only one element at a time. In CPP also, like in CPP, that's the rule. So hence we need to do it three times, because we need to push at the rate 20, right? Hence we need to do it in this way. Push back at 2, like not even 20, we will do it like 2, then again push back 0, right? And you just, else if there's no space, then um just push, I mean temp dot push back the element itself, the element itself, because we are making another temporary string, right? Here we are making another temporary string, right? uh, and return the temp itself, the temporary string which we made. Right, now your part comes, your homework is in this question, your homework is uh, to not use temporary, uh, like not to use third string. You need to use the given string only and do the problem. So this is your another homework. So I guess two homeworks related to string, no, three homeworks. Okay, so I will just note it right now here. One will be char array versus strings, and second would be the what was the last question? It was maximum occurrence, and this third, which I have done, which I have more or less done. But again, you don't have to use the third string. You can't use a temporary string here. Wait, someone messaged week 2. Yeah, exactly. Thank you for noting that. Uh, yeah, so these are the homework. Oh, sorry. So these are the some stuff here. Uh, yeah. Uh, okay. There are more number of questions. There's one question which is like a medium level question, which we will like. It's a sliding question based. So this is actually really important. Really important. Fine. So you guys need to listen this, and then we will end this. Fine. It's actually really important. So first I will just write that given a binary string. Also many people have this thing that strings does strings always have characters? No, it can contain numbers as well, right? 0 1, it can contain at the rate, it can contain special characters as well. Fine, so given a binary string means that 0 and 1s. Fine. And uh, an integer k. I will explain everything. Just hold on. Just let me write this, because it's actually really important question. And return. So you are given these two questions, these two things. Return maximum number of consecutive consecutive ones in a string. I will just write the question. Then you can ask me if you can flip at most k zeros. Now this might look little bit confusing, but I'll just give you one example. Let's say that we are 0 0. Let's say that we have 0 0 0 1 1 0 1 0 1 1. Let's say that this is the let's say this is a given thing. Okay, this is a given string to us. Okay, now here we have to return the maximum number of consecutive ones in a string if you can flip at most k zeros. K is given, let's say 2. Fine. Now you can, like, can someone just like unmute and tell that how can we flip like consecutive one, like how can we flip zero so that we can get consecutive numbers of ones, like okay, let's start from these two. Fine, if we flip them, we can get 1 1 1 1, so we'll get 4 from here, right? Is that fine? Now let's flip. Okay, now another example, that's 4. Fine. Now in another example, let's flip. These are done. Let's flip this and this, right? How many ones? How many consecutive ones? Now we get 1, 2, 3, 4, 5. 5. It's increased, right? Now let's say consider another example. Let's consider we are flipping some other zeros. Let's say we are flipping this and this. 1, 1. How many ones now? 1, 2, 3, 4, 5, 6, 7. How many ones now? 7. We need to return this number only. Got the question? Has anyone not understood this question? They can unmute and ask again. I can explain this again because it's a really important one. It is really important. Is this fine for everyone?
Could
Like,
you just repeat it once more?
yeah, sure. See, so we are given a binary string, which means that 0, 1, 0 and integer k. It's some integer k. We have to return maximum number of consecutive ones in a string, but the question doesn't end there. We can flip at most k zeros. We can flip at most 2 zeros. K is given 2, let's say. Okay. So, like if we don't flip the zeros, how many what is the maximum number of consecutive one which we can return? Can you tell? When we don't flip any zeros.
2.
2, exactly, 2. But if we are given that liability, if we are given that flexibility to flip 2 zeros, fine, then we can get, you can see the pattern, right? We can, like, if we make this 0, 1, we can get 4, like 7 and all. I explained this to you, right? So we are considering every zeros and making them flip, and then checking that if it is getting the maximum ones or not, right? Like in this case we got a window size of 4. Like now I said window, but yeah, I will tell you why. So here we got something as 4. Here we got 5. Here we got 7. So we need to first see, like, we need to make an algorithm which goes to checks every possible outcome and just returns the maximum number of consecutive ones. Got it? Is got it? So uh, it will be the longest. Huh. Fine. So, what we can do here is that, like the brute force method, what we can do here is that we can uh, maybe go with like maybe have some interval, check if make them 0, make them these zeros 1, and check if it is like maximum number or not. Okay, then again iterate, then again after that we can make this window to go another in another interval, make them 0, like, okay, I will explain it here only. This is a brute force method. Fine. So basically what we are doing is that we are making our window size a fixed window size. Fine. We are not, uh, you know, uh, making this flexible. We are just considering some window size. This will be a brute force method. We can, like taking this fixed window size, we can flip these ones. See, okay, 4 ones. Then checking for next, like, next step, we can again make this one, then 1, 1. So again this will return something 5 maybe. Then again we will I mean just shift this fixed window size, which will, this solution will be O of n square. It's even worse, so I don't even want to discuss this approach. I mean, not discuss this code, but yeah, basically what we are here doing is that we are just making it a fixed window is being designed here, and we are just shifting it and checking and all, right? uh, the more efficient way to do is will be something called as, like, now we will start with the sliding window, but it will be a it will be flexible, fine, according to our uh, needs, according to our requirements. So sliding window, I can give you one definition for it quickly. uh, then I will explain the approach. It will take, I guess, 15 minutes more. Yeah, sliding window. Okay, it's used when we have to find longest or shortest sequence. Fine. It is like whenever again this again like I said, like whenever you see a sorted arrays, maybe think of binary search. Fine. So again here, whenever in the question you see somewhat of we need to find longest or shortest sequence, longest or shortest subsequence. Subsequence basically let's say 1 2 blah 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 blah, right? Subsequence will be a continuous part of a sequence, like this is a subsequence. Fine. So whenever you need to find longest or shortest subsequence, we can think of sliding window, right? Just remember this point again. Fine. So again we find like windows with our different requirements and all, and we can form different sizes of windows according to needs, right? Now we will, you know, discuss this question. Fine. So please pay attention right now, because I will be discussing this 0 0 1 0 1 0 1 1. This is the given question. Fine. Now we are given let's try also, right? We are given k as 2. Fine, like k as 2, and we are given just k as 2, right? So now here I will define two variables, like zero count, basically how many zeros are there in a at a particular time of the window. I will have zero count as 0, and the max length which we have to return. This will be the basically this will be the answer which we will update as we go. Fine. Right now we will have two pointers as well. Start. We'll have two pointers as well. We will have start. Uh, this will go like this, and we will have e as well. End. We have two pointers. Like whenever we are defining a window, we will have two pointers. Will define two pointers. Uh, yeah. Just hold on. I think I should take it little in the lower side, right? Yeah. So starting. So this is the starting pointer, and this is the end like pointer of the particular window, basically. Fine. So for now, zero count is basically it is actually 1. So I will update it to 1. Fine. And the max length is also 1. Now, zero count is 1 and max length is 1. We can increment this e, right? Also, make note that k is the number of zeros. It should be like it should be the maximum number of zeros to be flipped, right? So zero count should not. I will just write this condition. Zero count should not exceed. It can be equal to k, but it should not exceed. Hence, you will write this case to consider. Fine. So E will shift here. Fine. Now, when E got shifted there, zero count will be 2 and the max length will be 2. Is zero count greater than K right now? No, right? No, it's not. So it's fine. It's satisfying the condition. Fine. S will stay there only because it is satisfying the condition. Hence, if it's satisfying the condition, E will go again forward. Fine. Now here we see zero count will be equal to 3 and max length will be equal to 3. Now we have this problem. Zero count can't be equal to k. Sorry, can't be greater than k. Hence, to compensate this, we should move starting point here, and this will go again to 2. You're getting this pattern right now. Is anyone having any problem with this? I will write
Clear,
the
bro.
clear or not?
Clear, bro.
Okay. I thought, yeah, okay. So I will also write this in a form of code right now, like 0k uh, if if str s like as in starting point is equal to 0, 0 count minus minus, because in this case, like particularly in this case, we have to go ahead, right? And e and 0 count is like first it was 3, so we are decreasing it to 2, right? Because s is has been increased, right? Hence we are writing this condition. Fine. And also s should be plus plus here as well. S will be plus plus here. This is just a pseudo code again. This is not a final code. So just, I mean, just to get you guys understand what's happening right now. Yeah, we are just dry running this case. Now, max L is 3, right? Max L is has also be decreased to 2, right? So oh no, max L will be 3 because we will go to here, right? Now we can see k is equal to 0 count is also 2, right? E is equal to a. Fine. Everything is fine as of now because k is number of zeros is also 2, right? So we can again increment this e here. Fine. We can see max length to be out to be 4 now, right? 0, 1, 2, 3, 4, right? Everything is fine right now, right? Now, again, if I go here, the 0 count will increase to 3, which should not happen. So, to compensate this function, to compensate this function will run because while 0a, this will go here. So, again, start will go here and we will again decrease it to 2. Is it fine till now? Yeah. So again, now we see, now we need to again increase the E because everything is valid as of now. Now we see number of 002 numbers, right? Like basically what we are checking is that we need to make a window which has k is equal to 2, right? Which we can flip maximum two zeros, right? Hence that window should contain only two zeros. That's why we are checking this condition again and again, right? Got it? So because that's what we did here also, right? We saw different kind of windows here, right? Some was giving us 5, some gave us 7. The one which gave us 7 had two zeros. By flipping them we got the most number of ones, right? This is what we will do here also. Fine. So now again, e is here, max length is 4, everything is fine. So I will increment it to here. Now we see there are how many zeros? Again it increased to 3, right? So again this function will run, s will come here. Fine. This will again go back to 2 and e will stay here and max length will be 5 because we are again incrementing to here. Fine. Everything is fine. Max length is 5 because went just here. Everything is fine. We have two zeros. So this function won't run. Now again e will go back here. We have this two function and this is the longest one, right? This is the longest subsequence which we could find which had two numbers which can be flipped, right? Hence max length also I missed the 6, it will be 6 here because 1 2 3 4 5 6, and again when end pointer comes at the last this will be 7, and when the end pointer when the end pointer comes at the end, like the end part of the string, we will run the max L. So this is the approach. This is what we will follow. We got this question. It's actually a really important question because here we are kinda playing with the sliding window. We are manipulating the string. We are checking a lot of conditions here, right? We had to define two different variables for solving these questions, right? So this is kind of medium level problem, right? So is it fine till now? Is anyone having any doubt in this question?
Fine, bro.
Yeah, is any yeah, okay. So yeah, so the code for this, I guess I will just discuss this as well. I mean, it's now, I think if you are like comfortable with strings right now, you guys can, code it out yourself also, but still I will, code it again. So let's say that we have this function, we are making one function, right? We are given one string which has this and we have int k. Fine. This is the thing. We need to define two pointers. start is equal to 0, int end is equal to also 0. Fine. Also, we have int as int of max, sorry, int of zero count, count count as 0, and also what we are defining here, max cell, which we need to return. Right. So for now we are starting one loop. We can do kind of this in the in C++. We can make this loop like this as well. Str dot length and end plus plus. Basically, we are just moving the end pointer and nothing. It's just a for loop. Fine. It's just a normal for loop. And now we are just checking if str end uh, if str of like, oh sorry, I have defined it here e, right? So that you guys don't get confused, I will write s and e. I will consider s and e only. So e plus plus, if str of e is equal to 0, what we do here, if the string at end is equal to 0, what we do, we increase the number of zeros, right? Zero count has been increased because we did that only, right? So we will just increase the 0. Whatever I have discussed here, exactly that only we are coding out in in the form of code, right? Now we can run that while condition, right? Like while 0 count should be greater than k, right? Should be greater than k. We can have one if string, if str of start is equal to 0, which means that, basically, which means that when s was coming here start and 0 was increasing, right? We can, what we have to do, we have to shift the s start to like in the next element, right? Hence we are shifting the start at the end, and then max length, max length will be, now we can have some max length as well. Max length will be maximum of max length, and the end minus start minus 1, sorry, plus 1, because the number, the it starts from 0 1 2, right? So this will be the thing, this will be the basically the code. uh, we can return the max length here, and yeah, that's done. This is the basic code. This is the code which we have to perform here to solve this question. So here actually I will just revise it. Like we are defining here, we are just defining the things which we have defined. I mean the 0 count max cell which will get updated. This is just a normal for loop. This will check if the string end has 0 or not. Fine, and it will just go on and on, right? Uh, Also, if start is equal to 0, I have missed one thing. Yeah, this thing. Uh, 0 zero count will also decrease, right? Because even also what I was doing is that whenever we were seeing that the start has got more number of zeros, we were increasing it, and we were, when it was becoming 3, we were decreasing it to 2, right? That's why we will define 0 count 2 is also, like if start is equal to 0, we'll define 0 count 2 and start plus plus. Fine, that's fine. And then max length is actually just the maximum of the max length and the end start plus 1. Means that the pointer which it, like the pointer's size which it will be on, it will be it will find just the maximum of it. Like at first it will uh, uh, like when this loop is running, it will affect the max length also, right? So max length will be updated again and again. It will just compare it with the end start, right? End start, and then it will just return the maximum length, right? End minus start plus 1 will have the updated value of the window size 7. It will have the 7, and hence the maximum will be, max length is 0 here because here is 0, 0 comma 7. What is the maximum of them? It is 7. So yeah, someone wrote this. I shared a jam file with the meeting. Yeah. So yeah, this is how we will solve this problem. And is anyone having any kind of problem in this question? It was actually something new. something medium level question. So is everyone fine with this? I will assume it to be fine only. Uh,
So fine.
uh, what is this jam file RN? I didn't.
Hello. Yeah,
Yeah, yeah.
sorry, I did it by mistake.
Okay, okay. Okay, fine. So till now, we have discussed today a lot of things. Sliding window problem. We will be providing you with sample questions of these topics as well. Fine, you guys can, use the same approach because this is the similar approach will be used here, right? Try to do questions of subsequences. Fine. And if you guys still have doubts, please ask in Telegram channel. Fine. If you guys have any kind of problems like the pace is very fast and all, anything, let me know right now, or maybe comment or write that in the Telegram channel, please. Fine. So till now, this is all which we have to do today. So yeah, any doubts overall in this class, in this today's class, they can ask right now.
Would you please upload the recording of this session by today
Yeah,
evening?
yeah, this will be this will be uploaded, and we will be providing you with the practice questions in the Telegram channel. Fine. So yeah, if no further doubts, we can wrap up. And yeah, and please remember to keep practicing those questions which we give, because just seeing the videos won't be enough, and even just seeing this course won't be enough for you guys, because you need to practice a lot. DSA just needs practicing, right? So yeah, I think we can wrap up. If no one has any questions, you guys can leave now. Fine, thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you, bro.